Welcome everybody. I hope you guys are all refreshed and reloaded, for this second session. Um, I just first of all want to thank you to the DTC community, right, for inviting us over and putting this great conference together. And it's been a great conference so far. So I work for a company called Solo.io. I'll give an intro about what we do, and I'm part of the APAC team, right? So we work closely with the sales folks, trying to come up with all sorts of solutions for our customers. But we're sort of focused on the APAC region, and we have teams in both EMEA and US. So the talk today is going to be solving multi-tenancy security concerns, right? It's a lot of words in this topic, so we're going to slowly break this down, and we're going to try and understand what this multi-tenancy thing is, right? Because that word has been thrown around, without much context. So we're going to sort of understand what it actually means. So a little bit about myself. I live in this small town in New Zealand called Tauranga. I don't know if any Kiwis in the house. I know there were some people in the in the workshop yesterday. I've got twins, daughter and son. This is just me just doing a hike with my daughter up in one of the mountains in Tauranga. And my experience is predominantly has been in sort of the developer space, but more recently I've sort of shifted my focus towards SREs and DevOps. Here's my credentials if anybody want to reach me. And about Solo, so Solo was actually founded in 2017, and our whole focus was trying to solve some of the application networking problems a lot of our customers had. We've got a huge customer base, right? Pretty big customer logos. I'll give you some examples such as SAP, Amex, T-Mobile. SAP is actually one of our biggest mesh customers. They run thousands of mesh deployments there, and the company is actually based, so the headquarters is based in Boston, but we've got teams all over the world trying to help and deal with a lot of the application networking challenges, right? I won't go too much into the product stack that we have. We've got a booth outside, so if anyone's interested in knowing what these are, come and talk to us. So the agenda of this talk is going to be on, we'll try and understand what this multi-tenancy thing is, right? And we'll look at what the current state of multi-tenancy in Kubernetes, and then we'll look at some ways of how you can cross boundaries, right? Cluster boundaries, how you can scale beyond a single cluster, not just within a single CSP or cloud service provider, but also across cloud service providers as well, so multi-cloud. And then I'll, hopefully, if the demo gods are with me, I'll try and do a demo, and then we'll sort of end it with where the future is sort of heading, right, in this space. So let's try and define what multi-tenancy is, right? It's the efficient use of infrastructure while providing cloud service providers, with robust isolation mechanisms between users and workloads. And the last two words, users and workloads, is really important, right, when it comes to isolation. And this, multi-tenancy could mean within your organization, you could have multiple teams, for instance, right? Development teams that they want some sort of isolation when they want to run applications. It could also mean cross organizations, but usually this is just a single organization, and that's where most of our customers are sort of heading towards. So what are some of the benefits, of multi-tenancy? The first one is a major benefit, right? You sort of reduce the operational overhead and complexity. uh, improved return on investment, right? Both from a capital and operating cost perspective, um, and accommodating both trusted and untrusted tenants, right? And then this last bit, I sort of kind of threw this in because it sort of enforces optimizations in your architecture as well. It sort of forces you to think outside the box when it comes to multi-tenancy. So let's quickly go through some of the current state or ways you can introduce multi-tenancy in vanilla Kubernetes, right? So we're focused on Kubernetes here. So in Kubernetes, when Kubernetes was first introduced, namespaces was definitely the way that they were trying to solve multi-tenancy issues, right? You sort of have this logical boundary that you can define through namespaces. And then on top of that, you can define things like RBAC, right? Role-based access policies and quotas. Again, you can define quotas within your namespaces, right, to define what sort of resource allocation you may have. And then network policies to isolate the workloads. So here's just a quick, depiction of what that may look like in terms of tenancies, right? Multiple tenancies. You may define the tenants as multiple namespaces. And then there's been like this introduction of virtualization within a cluster itself, right? Through this mechanism called virtual clusters. I don't know how many of you use virtual clusters in your organizations, but a company called Loft, came out with vClusters, which was highly popular to run virtualizations within a Kubernetes cluster, and that sort of solves some part of this tenancy issue, right? Because you can run these multiple clusters within your Kubernetes cluster, right? These are again defining logical boundaries, and then you also have organizations who may have multiple clusters, right? This is sort of obviously adding a lot of cost into management and operating. So what this is doing is you basically create or define a cluster per tenant. So if you have like thousands of tenants, that's thousands of clusters. And again, if you may have high-level, high availability, requirements, that would mean like double that cost, right? So the cost actually creeps up as you do this. Definitely not the most suitable mechanism here. I think you'll find that a lot of people aren't actually doing this type of thing, right? Creating clusters per tenants. But then if you want to have that sort of isolation mechanism, you'd definitely follow something like this from a security perspective. This is great and all if you're just talking about a single cluster, right? And a single cloud provider. But what happens when you sort of scale outwards, right? You might want to cross cluster boundaries, cloud boundaries, right, to multiple service providers. Like how do you manage that sort of thing, that sort of scale, and then how do you then add more and more clusters into this, so then you can sort of seamlessly define these multi-tenancy boundaries. I don't know how many of you actually have heard of Istio, service meshes in general. So look, some people. It's good. So service mesh basically allows you to, it sort of allows you to kind of define, certain policies like L7 policies, right? To have some sort of service isolation. But beyond that, what it allows you to do is just focus heavily on your business logic. So rather than being concerned about cross-cutting issues, right, with your architectures, it sort of allows you to just focus on business logic and leave some of the other requirements such as security, observability, load balancing, discovery, that sort of thing, to something like Istio or service meshes, right? Because it solves that problem of service security and communication. Now in Istio, there's, you know, if you look at Istio, there's a way to kind of define multiple clusters, right? Or multiple meshes as a single mesh. One of those mechanisms is called multi-primary, right? What that means is you have a service mesh in a single cluster, so per cluster, but then you somehow stitch those together into a single mesh. And the way Istio does it is by exposing the Kubernetes API, because it needs to somehow discover some of these services running in some of the other clusters, right? So there has to be some sort of discovery mechanism. And it does that by using the Kubernetes API. So, and it also sort of allows you to then federate the traffic across what's called a EastWest Gateway. So I've sort of indicated here a couple of gateways, right? There's one for ingress, so your inbound traffic. There's also what's called the EastWest Gateway. So this is solving your east-west traffic routing. So you can do federation across these clusters. Now you can add more and more of these, right, as you scale. It really depends on the use case. So this is running per cluster a service mesh, right? So in service mesh, if you look at their tenancy models, there's 3 types of tenancies or tenancy models. One is namespace bound tenancy model, right, which is what we're going to talk about. There's also a mesh model where you can have multiple meshes or even multiple clusters. We normally recommend going for the namespace one because you can, a lot of the times that adds, less cost and overhead. And you can use some of the GitOps practices here to kind of manage the configuration, right? This is all based on Kubernetes constructs, custom resources, so you can define some of these as policies, and you can inject into your existing GitOps flows. In this particular example that I've given, if you look at service A and service B here, for instance, service B is sort of has defined this service entry, right? What it does is it's sort of allowing service A to talk to it, right? So you can define these service entries, and from a consumer perspective, you can also define what's called the sidecar. That's quite important because the sidecar allows you to, define, who's going to be consuming these things, right? And another thing that it provides is optimizations, because you're basically in a service mesh. If you think about it, each service would actually know about all the services running in the mesh, regardless of whether you talk to those services or not. So one of the ways of optimizing that is by using what's called a sidecar. So this is why there's 2 different resources here, right? Sidecar and service entry. You can go beyond that by also using an annotation called export to. Again, with export to, that's sort of at the L7 level, allowing you to define what sort of namespaces that you can talk to. Similarly, with service A and service B, you can also define things like, hey, I'm only permitted to talk to, the service running in tenant Y, right? Or service B running in tenant Y, and the namespace ns-y in this particular example. So, what are the if you talk to your security teams, you probably get into trouble for doing something like this, right? Because you're essentially just exposing your kube APIs, right, for discovery, thereby compromising your security posture. So one of the ways at Solo that we've solved this problem, right, with Istio is to create a management plane. This management plane basically sits on top of these meshes, or Istio service meshes. And what this management plane allows you to do is the exact same thing that we previously looked at but not exposing the kube APIs, right? There's this thing called the agent that runs on the cluster, right, on the mesh, and this agent is what's actually configuring the Istio mesh here. By doing that, we can sort of reduce some of the security issues, with that previous architecture that we saw. Now these are all, secure channels, right? The communication between the agent and the management plane. The management plane is what's right at the bottom, right? Called the Glue platform server. And this is where the operations teams might actually, configure certain aspects of this mesh. You can also talk to the agent directly, but a lot of the times it's talking to this mesh directly, talking to the management plane directly. And beyond that, it's pretty much the same as the upstream SEO, right? You have a gateway entry point. You have a EastWest Gateway for doing federation across meshes. But the only difference here is that now you have this overarching management plane that's sort of setting everything up. And as part of this management plane, we've also provided a set of APIs. So these are all abstracted APIs, right? One of the pain points that we keep hearing from our customers is when they're using something like Istio, open source Istio, there's a vast array of APIs that they need to think about. So what we've done is we've sort of collated all of that into kind of a streamlined set of APIs. So that's all they have to use, to set everything up. And this would scale to however many clusters. And with the management plane, what I've indicated as the Glue platform server right at the bottom, you can also set up the management plane as high available, so it can also scale if high availability is a requirement. So I mentioned that Glue Mesh provides a set of APIs, right? Actually, two of those is what's called the Workspace and Workspace Settings. And this is what allows you to define tenancy boundaries, right? This is kind of similar to what we saw earlier with upstream SDO, with sidecars and service entries. But instead of doing that, we've sort of added this capability in Glue Mesh, allowing you to define a workspace, right? This is the very top level sort of boundary definition, right? So you can, in the workspace, you can say, these are my namespaces that I want to add as part of the boundary. And then you can tweak this even further by introducing something called the Workspace Settings. So in the Workspace Settings, you can say, this is what I want to import from, right? And this is what I want to export to. And these are like isolation rules that you basically introduce. So in this example, if you see, TMX is saying, this is where I want to, so if you look at the TMX workspace, it's basically saying, this is where I want to export my resources to, which is Team Y, right? And then in Team Y workspace, it's doing an import from. Again, Team Y can choose whether they want to import from or not, right? If they don't, obviously that's not going to work, right? In terms of being able to access some of the services running in Team Y's workspace. And then Team Y can also choose whether they want to export their services outwards. So this is how you sort of define these tenancy boundaries. And each team can then own this workspace settings, right? So as a developer, right, as a development team, you can sort of own this workspace settings and you can manage it on your own. And as an operator of the mesh, you can define what these workspaces are, right? Which is the top level one that you see. let's have a quick, well, let's do a quick demo, right? In this demo, I'm just gonna quickly show you 3 clusters and how you can define some of these declaratively, right? And use GitOps using Argo CD. Quickly start my environment here, right? What it basically does is it actually creates 3 K3s instances, right? As in VMs, and I'll just come back to the slides to kind of talk about what we're basically doing. So we just take this hypothetical example, right, of running these boutique store. There's 3 teams there: ops team, backend APIs team, front end team. Now each team will kind of own their own workspace settings, as we saw. That's a concept within Glumesh, right? And then they sort of define who can do what. Now in the case of backend API team, they've sort of taken a zero trust approach, where they've you have to define policies in order to accept any requests from an outside team or tenant. So we'll see how that's been defined. So the front end team just has a front end API or application, right? And the back end team obviously takes care of a bunch of services here, right? And like I mentioned earlier, they've taken a zero trust approach, so they're not accepting any requests from the front end team. And we'll see how we can introduce policies to let the traffic through. I'm looking at in the top pane. I'm sort of looking at the west cluster here. So there's a cluster in the so this is sort of a east-west architecture, right? So there's a cluster running in the west, and there's another cluster running in the east. So the applications are sort of distributed across the 2, and they're all K3s clusters here. And then you can also see the management server running, right, in Argo. And I'm also using Git here as the Git repo here, so then I can push stuff and then kind of automate the process of provisioning these applications. Right, so the first thing I'll quickly do is deploy my applications. So what this does is it just basically commits a whole bunch of configs and sets up Argo CD, so it can actually sync the cluster or clusters, I should say, and set everything up, right? So that looks like it's complete, and you can see the services just slowly coming up. So you can see that there's 2 repositories, one for the applications and one for the config, right? I won't dive too deep into the config itself, we'll just quickly look at one of these, right, to define how we've set up the workspaces and workspace settings. So if we take a quick look at the front end team's workspace settings here, you can see that there's an import from, export to, like I mentioned earlier, right? This is how you sort of define those service boundaries. And then they're also using EastWest Gateway here, right? Because they want to do some sort of federation between these clusters. And then the isolation part is quite important, because all that's saying is I want to mutual authenticate all my services running in the mesh, right? So let's quickly go here. Now, there is an issue, right? I mentioned earlier that the backends team has taken a zero trust approach, right? So we, as a backends team here, we still need to obviously allow for the front end team to talk to the services running in the backend team, right? So there's a couple of policies here that allows you to do this within Glumesh. Let me just quickly show what those are. So access policy. So through access policy, you could say, I want to let the front end team access all my applications running, right? So now if we go back into that online boutique, you can see that things are synced. And basically allowing the backend team, or allowing the front-end team to talk to the backend team. So let's go back to the slides, right? So very quick demo on how this works. Again, come and see us in the booth if any of you are interested in this. So where's this heading, right? As you saw, with service meshes, you always have to have that sidecar pattern, right? There's always a sidecar running in your service. So the question you might be asking, right? That's also adding a lot of management. So Kas, what's the point of all this, right? But we see as the future of mesh in a world where things are sort of heading, we see this sidecar pattern sort of slowly getting deprecated. So we're sort of moving towards a sidecar-less pattern. And we've done some work. I can't obviously give a lot of details here due to embargo issues and stuff, but we're sort of making some announcements in this space, some innovative announcements in the next few days' time around this. And what we'll do is we'll also push this upstream as open source. And then you can also play around with this stuff. In this sidecar-less model, you basically have a L4 proxy running in the node, and that's how everything's sort of done at the L4 level, right, at the kernel level. And if you need policy-based proxies, then you can introduce those as well as part of this. But you can see that the sidecar has been taken out of some of these applications. So if you're interested in this, come and talk to us. We're at the booth, and we can't go into too much detail on this, but I'm sure we can talk about some of the stuff here. So with that, I conclude this talk. Thanks, guys, for listening.